Our lesson for today will be looking at chemistry 1502. We are still busy with alkyne reaction. The topic for today is alkylation of alkyne ions. Let us start. Remember that we've learned how to form, we've learned the synthesis of how to form the alkyne ions using a strong base. Now in this lesson we are going to take it further from the alkylation of the alkyne ions. Now the general equation we will be using for this lesson video is we take it from the alkyne ion, we react it with an alkyl halide via SN2 nucleophilic substitution reaction to form another alkyne. This one, it will be a different type of an alkyne plus our halide ion. This synthesis we call it alkylation. Of alkyne. Ions. What you should know is that an alkyne ion is a strong base and a powerful nucleophile. Since you can see this is a negative reactant, so this will be our nucleophile. Then definitely sure this will be our substrate. We should know that this nucleophile can displace a halide ion from a suitable substrate, giving a substituted acetylene. And what is important for this synthesis to work, we need a very good substrate for SN2. So we know that the trend of SN2, or the substrate stability of SN2, methyl it's more stable compared to the primary, compared to the secondary, compared to the tertiary. So we need a methyl halide or a primary alkyl halide in order for this synthesis to work best, since it favors SN2. So having an alkyne ion as our nucleophile and a suitable substrate, which can be methyl or primary, which will favor the SN2 nucleophilic substitution reaction, it will form an elongated alkyne and our leaving group, which is the halide ion. Let us look at examples. The first example, let's say we have this alkyne ion, which by the way it's sodium alkyne. Reacting this with one bromo. Let's actually write the structure. Let's say we have CH3, CH2, CH2, and then we put its bromopropane. So what will happen is that this is the substrate, and you can see that it is primary, and then this will be our nucleophile. What will happen is that the nucleophile will attack the electrophile, the leaving group will leave. Then we are going to have our product as this is this part. Let me use a different part for this. Then this part will be joined here. So we have CH3, CH2, CH, actually doesn't make sense when you put it like this, because it attacks this carbon. So you're going to have CH2, CH3, no, CH2, CH3. This should be correct. And then this sodium will join this bromide ion to have sodium bromide. So you can see that we have extended our alkyne. A terminal alkyne. Look at this reaction using a different method now. The first reaction, we are going to react this with sodium amide. The second reaction, CH3 CH2 Br. So in one of the examples you'd see something like this, meaning that this is the first reaction, then we have to take the product, continue to the second reaction. So let us start with our first reaction. So let me say this is the first reaction. I'm going to use this color. So what happens is that this base will extract this proton, acidic proton, to form an alkynide ion. So we have an alkynide ion. With our sodium ion plus, actually I made a mistake here, it's supposed to be NH2. So we have NH3. Then one of this hydrogen has joined this, then we have ammonia. Then for the second reaction, we have our alkynide ion reacting with CH3 CH2 Br. In this case, our nucleophile will attack the substrate the leaving group will leave, then it will join our sodium. So from here we have our final product, or the major product. Plus sodium. I hope you can see. The next lessons we'll be looking at more examples which are practice problem, so that we can understand these reactions in detail. That's it for this lesson video. This is Rahula SJ. Thank you very much.